Hi, we are Integral Cost Consultants. The following project concerns a civil engineering measurement design project collaboration. A quantity surveying company was required to provide cost advice to civil engineering groups on their design solutions to a particular case study that they were assigned to. The quantity surveying students in their respective companies were required to engage in discussions with the civil engineering students with regards to a civil engineering project. The project was split up into 12 unique case studies that covered a different aspect of the project. The engineers were split into groups of 2 groups of civil engineers that would be assigned to a case study. The location of the project was Liesbeek. The lead consultants identified 12 areas of the project for the development and have approached various civil engineering design consultants to take each of these projects through the 4 stages of development on behalf of the client. The 12 case studies are dams, transport and roads, underground parking, apartment blocks, sheds, wastewater treatment plants, project water strategies, stormwater management, water towers, water treatment plants, water and fire reticulation networks, and bridges. The chosen project by Integral was bridges. This brief required students to design a new access bridge. As the island is separate from the mainland, the bridge is required to bridge the gap created by the Liesbeek River. The civil engineers proposed several unique pedestrian bridge designs. 3 different materials were used for the structure of the bridges, namely concrete, timber, and a steel and concrete composite. The bridge selected by Integral was a pure concrete bridge. The pragmatic nature and the design meant that the bridge met all the necessary specifications and requirements set out by the client. The project requirements and specifications were as follows: 2 traffic lanes, a cycle lane, and a footway on either side of the bridge. The project was also to be located at the existing west interchange, where the river will be narrowed down to 20 meters and have a single span of 25 meters. The project also required a provision for the accommodation of municipal and telecommunication services. It should also have the ability to sustain traffic loads now and in the future, and a second pedestrian bridge was also required to be designed by a second team. The description of the chosen project: Integral Cost Consultants have selected to measure the bridge group's concrete bridge. The scope of the works has been outlined under 2.1.2 above. The drawings used to measure this project may be found in the appendix. The Liesbeek Island project features all 3 sections covered in the civil engineering measurement course, namely site clearance, earthworks, and structural concrete. Integral Cost Consultants, as a result, will have the opportunity to assess and evaluate the project using the above-mentioned models. The project scope is to design a reinforced concrete bridge spanning 25 meters across the Liesbeek River in Observatory, Cape Town, the Western Cape. The purpose of the estimated cost is to outline the estimated costs based on the provided information received from the civil engineers. The accuracy of the cost estimate is based on the preliminary information provided by the civil engineers for estimating purposes.
The assumptions we made for measurements of the bridges are: firstly, the excavation depth is 2.25 meters deep below the NGL, and we assumed excavation for intermediate rock is the first 1 meter deep below the NGL, and the further 1.2 meter deep is hard rock. The precast elements that were identified were the concrete barriers and girders, and the allowances made for reinforcement for footings was 90 kilograms per cubic meter, for bridge slab was 100 kilograms per cubic meter, and for abutment is 120 kilogram per cubic meters. Site clearance was measured under SANS 1200D because the overall area was less than 1 hectare. So for SANS 1200D, that is earthworks, we measured items according to the payment references, whereby we had site preparation, restricted excavation, importing of materials, and extra over in all materials to provide working space around structure. And for SANS 1200G, we firstly had concrete structure where we had formwork, rough formwork. So we split in terms of vertical, and we had vertical formwork to concrete abutment and strip footings, and then for smooth formwork we had vertical formwork to breeze slab and raised curb. Reinforcement, we had mild steel bars and high tensile steel bars where we measured 25 millimeter diameters, and then we had extra over for 12 millimeters, 16, 20, and 32 diameters. And then for concrete, there was blinding, and we also assumed that we have 15 MPa strength for blinding, and for concrete, we had stronger concrete, that's 20 MPa for strip footings, and then for abutment, bridge slab, and raised curb, we had 25 MPas. The finishes we allowed for were wood floated for bridge slab and abutment, and we had expansion joints as well between abutment and concrete bridge slab, and concrete barriers, in between precast concrete barriers. We also had in between precast girders, between precast girders and abutment. Lastly, we measured HD bolts and miscellaneous metalwork.
During the course of civil engineering SimOffice, integral cost consultants had to give advice to the civil engineers. Besides giving general design advice about how contractors work on site, that is, how they set up the works and preliminaries, we had 3 meetings with the engineers where we had to explain to them the 60% and 40% rule, whereby 60% is the building cost and 40% is additional cost. Integral cost consultants give the civil engineers a basic understanding of the preliminaries, the contingencies, escalation, and we also explain how professional fees are calculated. Additionally, post BOQs were provided to the civil engineers for the rates. Here's a template that was also provided to them. They basically had to plug in their building works and then generate a preliminary amount, contingency amount, escalation, and a professional fees amount. That was also added. In conclusion, integral cost consultant had a better understanding of the civil engineering works and how the designs look like. We also had a better understanding of the SANS 1200 documents and how it's different from the ASAQS standard system and how the works are measured under the SANS document when compared to the standard system. And lastly, we had a better understanding of the professional communication with the civil engineers. Thank you for your attention. Goodbye.